Applications of a quadratic function. Given a ball is thrown into the air with an upward velocity of 48 feet per second. Its height h in feet after t seconds is given by the function h of t is equal to negative 16t squared plus 64t plus 1. So question A, what is the height of the ball after 1 second? So we're going to use this model. Then we will substitute 1 to t. Then we will simplify. 1 squared is 1 times negative 16 is negative 16. 64 times 1 is 64. Then write down plus 1. Then simplify negative 16 plus 64 plus 1, and that is 49. This tells us that the height in 1 second is 49 feet. Okay, our final answer, the height of the ball after 1 second is 49 feet. For our question B, how long will it take the ball to reach its maximum height? And for our question C, what is the ball's maximum height? Okay, so we're going to answer these two questions at once. So first, we're going to prepare an x and y axis, where x here represents the time in seconds, and each interval is 1 second. And for our y axis, this represents the height in feet, and each interval is 20 feet. Now, imagine that there is a ball here thrown upward with a velocity of 64 feet per second. So it goes up, so normally it goes down, of course. So notice that the path of the ball is a parabola facing downward, because our model here is negative 16, so it means our A here is negative. So normally the parabola opens downward. So in our question, how long will it take the ball to reach its maximum height? Remember, the maximum height of a parabola is the vertex itself. So it means if we will get the vertex, we will also get the maximum height and the time when it reaches its maximum height. So from our given, h of t is equal to negative 16t squared plus 64t plus 1. So to get its vertex, so we will just transform this into vertex form. So we will isolate this plus 1. Then on the other side, it is negative 16t squared plus 64t. So we can factor this by getting its GCF, which is negative 16. So it becomes negative 16 times quantity t squared minus 4t. So we leave a space here for the third term because we want this to become a perfect square trinomial. And to get the c, to make it perfect square trinomial, we're going to get the b, which is negative 4. Get its half, it becomes negative 2. Multiply it by itself, it becomes positive 4. So the third term should be positive 4 to make it a perfect square trinomial. Then since we add 4 here, we must subtract 4 on the same side so that the value will remain. Okay, so since this positive 4 is being multiplied to negative 16, we must multiply also this negative 4 to negative 16. Then simplify. So we just write it down. Then negative 4 times negative 16 is positive 64. Then simplify it further. 1 plus 64 here is 65. Then we just transform this t squared minus 40 plus 4 into exponential form, which is quantity t minus 2 squared. Then we just write down negative 16. So it is now in a vertex form of quadratic function, wherein we can get easily the vertex, which is 265. Here we go. So this point here, this is the vertex represented by this coordinate 265, wherein this 2 here is the time, and this 65 is the maximum height. So the question, how long will it take the ball to reach its maximum height? We're talking of the time, so it will take 2 seconds for the ball to reach its maximum height. Then for question C, what is the ball's maximum height? Obviously, it reaches 65 feet. So the ball's maximum height is 65 feet.